Alright, welcome to the lab. Let's talk about today's testing rig information so that we can get into these tests as quickly as possible. Today, some of the software that we are going to use is we are going to run this all through Kubernetes in my home lab here. We are going to be using LocalAI. LocalAI is a great project that allows you to run large language models in your Kubernetes cluster or in a Docker container or just locally. I like to use it because it runs very well in my Kubernetes clusters and makes my life very easy, so I will shout that out and shout out Mr. Muddler here for making that for us. We are also going to be using Streamlit. This application that you're seeing in front of you will be using some LangChain and some Excel. Alright, let's get down to the hardware because that's probably what you're all here for. Today we are going to use a GPU node inside my cluster. Its base specs are running a Asus WS-X299 Sage 10G motherboard. This is a 10 gigabit with the capability of running up to 6 or 7 GPUs based on PCIe lanes. It has a Core i9-7960X in there, which is 16 cores up to 4.2 gigahertz. That doesn't really matter because today we are going to offload the large language model to the GPUs for all the testing. It's got 256 gigs of DDR4 RAM. It's got a couple of 2 terabyte NVMe drives in there for the Docker, Kubernetes, and the model storage. So everything is running off of NVMe in it. The GPUs that we're going to use for today's test, we have 6 PNY 4060 Ti's with 16 gigs of VRAM each. These are fairly cheap CPUs for running LLMs and AI and, plus if you like gaming on the side. These cards will all run in PCIe 8X. That's what these cards support, and the motherboard has enough PCIe lanes in order to drive them all at 8X, and you can see that up here. This is that node. The LLM that we're going to be running inside LocalAI today is Llama 2 13B. Why have we chosen that one? That model, when loaded onto a 16 gig card, will basically fill it completely yet still run. So that's our easiest way of comparing single to multi-GPU today. How are we going to run these tests? We are going to use a static 100 token based prompt. So the same 100 token based prompt over and over. We're going to run the tests 10 times each in single GPU, dual GPU, triple GPU, quadruple GPU, and work our way all the way up to 6 of these 4060 Ti's. We are going to record the prompt evaluation time, the total time it takes, the prompt token per second, and the evaluation token per second, and then we will compare our results here in the end. Alright, so let's go ahead and move over and start doing the actual test. What do you guys think? So we are first going to double check that we have this node all set up to only use one GPU right now. Alright, so you can see that it is set up to use only one GPU. Let's go ahead and take a look at the logs so that we can get the timings off of this. I'm going to stream the logs over here. We're going to flip back to our app. We have just a little, this is our 100 token based. It's basically going to ask them to, here, well, let me just read it to you. Can you write me a GitHub action that will echo hello, then build a Docker container from the Docker file called testing Docker and report the status in the log. If that step is successful, then it should be able to log into Docker Hub, then push the Docker image with a tag. This is exactly 100 tokens with the system prompt. We're going to go ahead and hit send. This first time we're going to ignore the timing on this. The reason why is because the model is not loaded. So this is what I consider unloaded timing. It first has to go through, split this model up, and it's offloading everything to the GPUs right now. So we're letting it load. We can see that it's finally completing, and I'll show you guys an example of what the timing looks like after that. We can see it's still streaming through here. Gave us a pretty decent answer. We can see that it's exactly 100 tokens. It took about, 273 milliseconds or so, and we were averaging about 26 to 27 tokens per second on the evaluation time. But we, again, are going to ignore this one because that model was unloaded, and you can see that we were only using a single GPU over here. So let's go ahead and send this again, and we'll start to record the timing there. And repeating back that same answer to us. And now let's take the timing and actually record it. So that first one is 261.73 milliseconds. The evaluation time was 15018.89. The total time was 15280.62. The prompt token per second was 382.07. And the evaluation tokens per second was 26.77. Now remember, this is all on a single GPU. I'm going to go ahead and run the next 9 tests and save you guys from having to listen to me. We'll fast forward to it, and we'll come back when we're ready to move on to the dual one. Alright, and that was the last one for single GPU testing. Let's get these data points in. And we'll take a look at our data here. So that was 10 runs, and you can see it does change a little bit, but you know, pretty much very, very little across the runs. But we can see down on line 13 here that we actually have our averages across the board. Let's go ahead and move over to doing the dual 4060 testing. So let me swap over to that sheet, and we will go set that up. Alright, to set that up, basically we're going to need to patch that deployment to tell it to actually use more than just that one GPU. So what I'm going to do in here is I'm just going to go add 0, comma, and that's going to give us 2 GPUs to actually work with. We can see that that was patched off to the side. Let's make sure it actually took place. Alright, still waiting for that other pod to delete. And there we go. We can see now that we're showing up with 2, and it cleared the model off out to the side. So let's go back and watch the logs again. And we are going to resend that same exact test at that same exact endpoint, except for this time we are going to be using 2 of the GPUs instead of just 1. So same thing, we're going to do it. Let the model load, and this time it's actually going to split the model in between 2 processes and 2 of the GPUs that you can now watch going. So again, we're not going to take this first timing, we're going to let it load up. And there it goes, responding to us with basically the same response we've seen a bunch of times already. Okay, now we've got our initial loaded model, so it's ready to go. Let's start the testing on version 2, and again, I will come back when we're ready to move on to triple 4060s. Alright, that was the last one for the dual GPU tests. So let's take a look at the averages down here. And then I'll show you just real quick what the averages were for the single GPU. Now again at the dual GPU, okay, well you guys tell me what you're seeing. Let's go ahead and flip over and continue to test. Let's move over and let's do 3. Go over and we need to patch that, and we'll add in a third GPU, number 2. And we'll go ahead and let that deploy. Give it just a few minutes here while it terminates the other one. We should also see the models drop off over here when it restarts. Okay, there we go. And 1, 2, 3, we're up to 3 4060 Ti's. Let's go back and watch the logs. And then remember, we're going to do the same thing. We're going to send it once and let it load across the 3 GPUs this time. And we can see it loading up. And now we've got 3 GPUs in the mix, and it's responding to us. But again, we're not going to include this time because of the fact that this was actually unloaded. Alright, we'll give it a second here. And let's start the first test on 3 GPUs. And just like we did before, I'll bring you guys back after a quick fast forward and we'll go up to 4. Alright, that was it for the triple ones. Now let's again give you guys a little look at the review of the averages. There's the triples, there's the doubles, there's the single. What do you think is going to happen when we go ahead and add a fourth in now? Let's go ahead and give that a shot. We'll back out of this. We're going to go patch that and add in a 4th GPU. We're going to go ahead and let that deploy. It's going to terminate the old pod and bring in a new one for us. We'll see the models fall off of the 3 GPUs and we'll bring in a 4th one. I'm curious, what do you guys think the data is telling us now? What do you think is happening as we add in more and more GPUs and continuously run the same exact test against them? Are you seeing patterns already? Do you have expectations that you're expecting to get out of the end of this? Let's take a look. Make sure we've got 4 GPUs showing up. 1, 2, 3, 4. Alright, let's go right back into it. Get the logs going. Remember, the first one doesn't count because the model is not loaded. This time we're going to see it spread across 4 GPUs and kick in that 4th one over here. Now it's responding to us. We're going to get this response. We'll give it a second and then we'll go dive right into our tests and see where we get from there. So there's the first one that was unloaded. Let's send the first actual one with the model already preloaded into the system. And just like before, we'll start recording these answers and I'll bring you guys back when we bring all 6 of the 4060 Ti's into play and end up getting what we see out of that and go over all the final results. Alright, last one here. Let's get the data in. 43. I know, boring data, right? Alright, so that ends our fourth one. Now let's again take a look at the averages here. Take a quick peek. There's the triple, there's the dual, and there's the single. Anyone seen any pattern so far? Alright, let's go ahead and take the last and final jump and bring all 6 of those GPUs in. So we need to go over and we're just going to patch this with an all. And we're going to let this one terminate and roll out to the new container. We should see the models disappear like normal off to the side here. And once that happens, we'll double check and just make sure that we're seeing all 6 GPUs before we start our test again. Alright, come on. You can do it. Alright, let's take a look. What do we got? 1, 2, 3, 4, 5, and 6. So let's get the 6th one started. Get the logs up. We'll send the initial one just to load up the Llama 2 13B model across all 6 cards. We'll wait for it to start spitting out. We'll give it a second and we'll go into our last series of tests on 6 GPUs. And then we're going to come back and take a look at all of this data at the end. So hold on. Alright, that was the unloaded time. Let's go ahead and give it a second. And there goes our first loaded prompt time. Anyone got any final guesses before we go into fast forward? Put it down. Alright, that was the very last one. Here's the averages for the 6 GPUs. Let's take a quick look back. There's the one for 4, there's the one for 3, there's the one for 2, and the single GPU. So now that we have all this data gathered, this is your last chance to make predictions before we go take a look at all this data. So let's go ahead and bring up the charts and see what we're looking at. Alright. So this is our prompt evaluation time comparison. If we're looking across the data, does anyone notice anything there? It's pretty minute. Remember, it's pretty minute. Alright, let's flip over to the evaluation time, which is normally what most people are going to be heavily concerned about, is what is getting your response back to you. Notice anything here? Again, I'm not going to interpret this data for you guys. I am just absolutely going to show it to you. Alright, let's go ahead and take a look at the total time. Again, you guys see a correlation going on across here? And if we look at the prompt tokens per second, if you look at these differences, there's very little. And down to the evaluation token per second, which is pretty much what everyone is going to go off of when you hear tokens per second. It's the evaluation tokens per second. So if we look at this, it's almost an exact duplicate. So what does this mean for you? You can take this data, look at it, and decide what it means to you for your home lab. Overall, these 4060 Ti's actually perform very well for a home lab situation in a cost per gigabyte of VRAM when it comes down to that. They're pretty quick. And you can see across the board, it's easy to scale your VRAM just by splitting it across multiple cards. And then you guys let me know what you think about the performance. For me, any hits there, which I don't see much, is well worth it to run multiple GPUs and save yourself some money when it comes to big, giant VRAM sized GPUs that cost just a literal fortune these days.